Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 years CBSE board chemistry questions part 14, in which we are going to discuss the alcohols, phenols and ethers chapter. Here the question number 1 is, convert the following: ethyl magnesium chloride to propan 1-ol. How we can write the structure of this? Ethyl magnesium chloride, CH3, CH2, This is ethyl chloride. So if I use MgCl, ethyl magnesium chloride, so that can be converted into propan 1-ol. Propan 1-ol in the sense total number of carbon atom is 3. So CH3, CH2, CH2OH. So here we have to listen very carefully. So in reactant side we have how many number of carbon atoms? So 2 carbon atoms. So but in the case of product side we have 3 number of carbon atoms. So we have to add one more carbon atom to this reactant. So what kind of carbon atom we can add it? So if suppose we need to get alcohol, so it's a good reducing agent. So we have to the product should get reduced. By the way, we have to use some oxidized product. By the way, accordingly I have to use formaldehyde, HC double band OH. This is a 1 carbon containing aldehyde, which will be going to react with our reagent ethyl magnesium chloride, CH3 CH2 MgCl, in which how the reaction mechanism happen? As we know that this is minus, this is 2 plus, this is minus. This minus will come and attack this. By that way, I am getting a product. So here CH3, CH2, along with that. So one more product is getting formed. Am I right? So here C double band O. Instead of that, we have C single band O minus. Along with that, I will be getting one hydrogen. Here also one hydrogen. So this HH, and in which this carbon atom, the CH2 is getting attached. By that way, here our Mg plus, so that MgCl will be getting attached. This is an adduct formed during the reaction. If once adduct is getting formed, we have to hydrolyze this adduct. By the way, I will be getting a product. So H and OH, I will be getting my final product, that is CH3, CH2, one more CH2, here I will be getting OH. This is my propan 1-ol. Are able to understand, student? So initially we have 2 number of carbon atoms, so that should be converted into 3 carbon containing alcohols. So that should be 1 degree alcohol. That is what we have to use, aldehyde. Okay, are able to understand, student? And next question is, give the mechanism of ethanol which will be reacting with HBr to form ethyl bromide. How we can convert this mechanism? So this is a very simple one. CH3, I will be writing like this, CH and H, here also OH. Okay, if I used HBr, so which type of mechanism, whether it's a kind of a nucleophilic substitution reaction, am I right? So here, whether it follows SN2 or SN1. So as we know that SN2 mechanism. Why it is SN2? Because it follows, and usually it's a 1 degree alcohol. So 1 degree will always preferably undergoes SN2 reaction. So if you don't know about this concept, please go and watch my previous video about SN1 and SN2. So you will be getting a clear idea about this. And here the Br minus will be acting as a strong nucleophile that will always come and attack from the back side only, because the front side will not be able to attack, because here repulsion is there. That's what it can come and attack from the back side. So here how we can get the mechanism? That is nothing but here this carbon. Here also one hydrogen is there. Here also one hydrogen is there. And here CH3 is there. Okay. So in which the Br minus will come and attack. At the same time, this OH minus will get cleaved. Okay. So it is a single step process. By that way, I will be getting a product like this. So what I am getting the product? Here C, one hydrogen is there, and here CH3 is there, and here I will be getting a bromine. Are you able to understand, student? Here always I will be getting a inversion product. Here it is a inversion. So inversion of configuration product I will be getting. That's all about the mechanism of this reaction. Are you able to understand? Okay. And next one is give the chemical test for ethanol and phenol. This question was asked in the year of 2013. It is a very simple question. Suppose if I am using a ethanol CH3 CH2OH. If I perform C6H5OH, this is phenol. Okay. So if the phenol, if it is reacting with FeCl3. So what happened? So suppose if I taking this like this, so I'll be getting 3HCl is getting formed. Along with that C6H5O, there will be thrice and Fe along with 3HCl. So here this is violet color. Violet color is getting formed because of that complex. But in the case of if it is react with FeCl3, there is no color. Okay, by that way we can distinguish both the thing, phenol and ethanol. Are able to understand, student? So here is nothing but FeCl3 will react with the phenol to form violet color, but here FeCl3 will not able to react with to form a color. Next question, draw the structure of the product formed if the following alcohols are oxidized. Assume that if an excess oxidizing agent is used. So our ultimate aim is they is getting oxidized, and moreover that they used oxidizing agent, and excess amount of oxidizing agent will also be used. So strong oxidation will be taking place. By that way I will be getting a product CH3, CH2 and CH2, here COOH. So here nothing but this CH2COOH will be converted into COOH. Okay, in presence of oxidizing agent. If excess amount of oxidizing agent will be taken, the ultimate product will be getting acid. So here 2-butanol will be given. 2-butanol, butenol. What is a butenol? Otherwise butenol or 2-butenol they will be given. So how many carbon atoms butenol in the sense? 1. That is CH3, CH. In second position I have double bond CH, CH2OH. This is the structure of butenol or 2-butenol. Okay. So once it is getting oxidized, what will be getting the product? The same thing. CH3, CH, double bond, CH, COOH. Buteenoic acid. This is buteenoic acid. Are you able to understand? So this is called nothing but buteenoic acid I'll be getting. Okay. So here I'll be getting a product as if I'll be getting a product like this. This is our product. Okay. Are you able to understand, student? And next one is 2-methyl-1-propanol. So we have to write the structure 2-methyl-1-propanol. So first we have to write the structure of propanol. So they mention clearly first position OH is there and 2-methyl, first position, second position. In that position I will be giving methyl group. If it is there, if it is getting oxidized in presence of a excess amount of oxidizing agent, I will be getting a product. The same thing here also CH3, C and CH3 is there. Here also one H and COOH. Okay. So 2-methyl-propanoic acid. 2-methyl-propanoic acid. 1, 2, 3, 4. Okay, fine. So are you able to understand, students? And next one is acid catalyzed dehydration of tertiary butanol is faster than that of N-butanol. Explain. This question was asked in the year of 2011. This is very important question. So acid dehydration reaction. Dehydration. What is the meaning of dehydration? So dehydration is nothing but the removal of water. So removal of water molecule. Okay, how we can remove it? Say for example, I have to take tertiary butanol. So tertiary butanol in the sense. So this is a structure of tertiary butanol CH3 OH. And acid catalyzed, they said. So in presence of acid. So here OH, the functional group that is which is having lone pair of electron, that lone pair that donate a lone pair of electron. By the way, here CH3, C, CH3 and CH3 here OH, and one more H is getting attached because of donation of electron, it got positive charge. Because of that, in a single oxygen, 2 hydrogen is there, so it needs to remove as water molecule. By that way, I will be getting a product like this, CH3, C, CH3, here CH3, along with that one positive charge is there, because if this bond is getting break, it need to get neutralized. By that way, you will get positive charge. By that way, I will be getting carbocation. This carbocation formed here is 3 degree and N-butanol. Now we will take N-butanol. N-butanol in the sense, what is that? CH3, CH2. So here CH2 and CH2OH. This is N-butanol. If suppose this also involved in acid catalyzed reaction, by the way, the same thing mechanism will happen. This also donate electrons. By the way, here CH3, CH2, CH2, CH2O. Here also one H. Here also one H. Because of that donation of electron, it got positive charge. So the same way the water molecule is getting eliminated, by that way I will be getting CH3, CH2, CH2, CH2 and one positive charge is there on that carbon. So here now we can compare it as a 1 degree. So as we know that, so 1 degree carbocation, 3 degree carbocation, which one is more stable? So 3 degree carbocation is more stable. So according to carbocation order of stability, so usually 3 degree, then 2 degree, then 1 degree. According to that, this will be reacting very faster because it forms a 3 degree carbocation. That is what? It reacts much faster when compared to this one, because it forms a unstable when compared to this one. When compared to 3 degree carbocation, 1 degree carbocation is unstable. That is what? It is a stable carbocation, so that the reaction will be very faster. So in acid catalyzed dehydration of tertiary butanol is faster in than that of the N-butanol. Because of that, 3 degree carbocation formation in this case. This is a 1 degree carbocation, that's what the reaction will be very slow. Are you able to understand, students? So thank you so much for watching. Please don't forget to subscribe my channel. Please go forward to others to get benefit. Thank you so much for watching. Thank you once again. Thank you.